Well, good morning, everybody. Today we are continuing 5-1, which is the second day on review on properties of exponents. And today we're going to learn a total of 4 rules that you probably have seen it back in middle school. So before I introduce you the new rules and the shortcuts, let's review the reasons. So let's discover 4 discoveries of these rules right here. So on the review sections, the first one is called power of a power. Now let's show it for a moment. So if I were to expand this, right, 4 power means I want to write the same thing 4 times, isn't it? Whatever in the parentheses 4 times. So you're going to write 2 to the third times 2 to the third times 2 to the third times 2 to the third like this, right? Now, of course, some of you may remember the shortcuts of what you're going to do with these exponents, but if not, let's write it out more. So 2 to the third means 2 multiplied by itself 3 times, correct? And then you bring down the multiplication sign, which I'm going to write it in a larger multiplication dot. And then you're going to write 2 times 2 times 2 3 times again. Then you're going to write 2 times 2 times 2 3 times again. And then you're going to write 2 times 2 times 2 3 times again. Then you count how many 2's are there total. And if you were to count it correctly, you notice that there are 12 2's multiplying each other. So it's going to be 2 to the 12th power. And you don't have to calculate what is 2 to the 12th power equals to, because it's going to get you a very, very large number. So we're not going to spend time finding out what's 2 to the 12th power. Just leave your answer as 2 to the 12th power. So my question is, can you find out what is the pattern between the 3, the 4, and then the exponents 12? Is there shortcuts that you could find? Yes. So if you look at it, 3 times 4, you get 12. And with the base 2, you don't do anything with the base. You just keep the base the same. And that will be the shortcut to deal with problems that has power of a power pattern. Let's go to the next discovery. What about power of a product? So if you have more things raised to the third power, what do? Well, let's show it for a moment, just for once. So I'm going to write whatever inside the parentheses 3 times. So 2 to the cube x squared, multiply 2 to the cube x squared, multiply by 2 to the cube x squared like this, right? Now, of course, you could write it out. So 2 to the cube x squared means 2 times 2 times 2 times x times x. That's what 2 to the cube times x squared means. Then you bring down the multiplication sign and you write another set of 2 times 2 times 2 times x times x. Then you bring down the multiplication sign and then you write another set of 2 times 2 times 2 times x times x. So from here, you're going to find out, well, how many 2's are there total, which is 9 of them. So 2 to the 9th power. How many x's are there total, which is 6 of them, so x to the 6th power. So my question is, well, do you see a pattern between these exponents, 3, 2, 3, and these exponents, 9 and 6? Well, the pattern seems to be a little bit less obvious, but you could still guess it, that if you do 3 times 3, you get 9. And if you do 2 times 3, you get 6. So the pattern is, well, if you see an outside exponent with some inside exponents, you're going to distribute the outside exponents to the inside exponents. So 3 times 3 is 9, 2 times 3 is 6, right? So that's your shortcut for something like power of a product. Let's continue more on the discovery. So this time we have something called quotient. So if you have 2 to the 5th divided by 2 to the 2nd, what do? Well, let's write it out. Let's expand it. 2 to the 5th means 2 times 2 times 2 times 2 times 2, multiplied by itself 5 times. And then 2 squared is 2 times 2. And remember back in middle school, whenever you have the same thing top and bottom of the fraction, you could cancel them. So you're left with 2 to the 3rd power on the numerator. So you write 2 to the 3rd power over 1, which is the same as 2 to the 3rd power. So let me ask you, do you see a pattern between 5, the exponents 5, the exponents 2, and the exponents 3? Yes, you just subtracted 5 minus 2 and you get 3, so that's your shortcut. Let's try another shortcut. What about this one? So let's same thing, let's write it out. So the numerator, I have x times x, and then on the denominator, I have x multiplied by itself 5 times, like this. And then when you see the same thing on the numerator and denominator of the fractions, you cross them out. So you're left with x to the 3rd power on the denominator. Now there's nothing left on the top, you still have to write something. You're going to write 1 over x to the 3rd, like this. So my question is, sometimes your answer is on the numerator, which is the top of the fraction, and sometimes it's on the denominator, which is at the bottom of the fractions. So how do I know when is the answer going to be on the top and when is the answer going to be at the bottom? Well, the pattern is all you have to look at is where has the larger exponents. If there's a larger exponent on the top, your answer is going to be on the top of the fraction, which is numerator. If there's a larger exponent on the denominator, that means your answer is going to be at the bottom of the fraction, which is the denominator. Okay, so you write your answer following the position of the larger exponents, either the top or the bottom. Okay, so that's your shortcuts. The last one is called quotient to a power. So let's take a look at this one. Well, this seems to be like a monstrous problem, but we're going to break it down. So we're going to write the same thing 3 times. So whatever inside the parentheses, we're going to write it out 3 times like this, right? So 3x squared over y to the 6 times 3x squared over y to the 6. Multiply one more time, 3x squared over y to the 6. Then from here, you have 3 times 3 times 3, which is going to get you 3 to the third. And then x squared times x squared times x squared. Now, if you expand it and count them, there should be x to the 6th power. Likewise, if you expand all the y's, you counted that there will be 18 of them. So it's y to the 18th. So my question is, do you see a pattern between the exponents of 2, 3, 6, and these 3, 6, and 18? Do you see a pattern? Very similar to the previous discovery, all you have to do is have the outside exponent distribute to the inner exponents inside the parentheses. So 2 times 3 is 6, 6 times 3 is 18, but then I don't see an exponent for the 3 here. Well, there is an invisible 1. So 3 times 1 is 3. So whenever you do the shortcuts, make sure that every basis, right, in this case the bases are 3, x and y, make sure that every single basis has its own exponents. If there's no exponents, make it visible. So there's an invisible 1 for every single basis that has no exponents. Okay? So these are the 4 discoveries that will lead to the shortcuts that you will learn in lesson 5-1, day 2. Let's take a look at that. Well, in this lesson 5-1 day 2, we're reviewing on properties of exponents, and today we're going to learn 4 more rules. The first one, just like the first discovery on the review part of this video, is called power of a power rule. It tells you that if you have power with raised to another power, all you have to do is multiply the 2 exponents while keeping the base the same. So let's take a look at example 1. So if you have 2 to the 6th power, and raise it to the 2nd power, all you have to do is keep the base the same, and you do 6 times 2. So 6 times 2 would get you 2 to the 12th. And then that's it. Very, very easy, isn't it? Then, in another example, part B, if you have x to the 6th power raised to negative 3rd, you do the same thing. So you do x, keep the base the same, and you do 6 times negative 3. So remember, positive times a negative is negative. So I have x to the negative 18th power. But hold on, we're not done yet. Remember, you cannot leave your answer with negative exponents. So what you do is you make it a fraction, x to the negative 18 over 1, and then you do the circle arrow like this, right? So that way, once you move it to the other side of the fraction, it becomes positive. So your answer is going to be 1 over x to the 18th power. Okay? Now in part C, same thing. It's just that it's a bit longer, but the process is the same. So for the x's, you multiply the 5th power and the negative 2nd power. So you have x to the negative 10th. And then for the y, you do negative 6 times 4. So it's going to be y to the negative 24th power. Well, again, you're not done yet. So you're going to make it a fraction. X to the negative 10. Y to negative 24, put it over 1, okay? And then you do circle arrow twice, right? So you're going to change these negative exponents to positive exponents by moving to the other side of the fractions. So it becomes, the denominator is x to the positive 10, and then multiplied by y to the positive 24th power. There's nothing left on the top of the numerator, so you're just going to put a 1 up there, and then that's your final answer. In example 2, you're going to learn another rule, which is called the power of a product rule. So if you have multiple bases that raise to power, all you have to do is distribute the outside power to the inside power, and then you get a to the n times b to the n. Let's take a look at that. So in example 2a, you have 4x raised to the 4th power. Now inside of parentheses, there's 2 bases. The first base is 4, the second base is x. They don't have an exponent, so you first, on the first step, is make the exponents visible. If you don't see an exponent, just put a 1, exponent 1 on each of the bases. So that becomes 4 to the 1st times x to the 1st. Then after that, you distribute the exponents like this, right? And then you get 4 to the 4th power times x to the 4th power. And then that's it. Now, of course, if you want to do more work, you can find out what's 4 to the 4th power. So 4 times 4 times 4 times 4 using a calculator, you get 256 x to the 4th power. So either way is acceptable. Let's take a look at another example, example 2b, which is 4a to the cube b to the negative square c, and then everything raised to the negative 2nd power. First of all, there are 4 bases inside this parentheses. There's a 4, there's an a, there's a b, there's a c. Make sure that everything has its own exponents. If not, then put a 1 there. So 4 doesn't have, so we're going to put a exponents 1. C doesn't have an exponent, so we're going to put a exponents 1 there. And then after that, you're going to distribute the outside exponents to the inside exponents like this. Okay. Now you're going to keep the base the same, so you're going to have 4 to the negative 2 times 1, which is negative 2. For the base a, you do 3 times negative 2, which is negative 6 power. For the base b, you do negative 2 times negative 2, which is positive 4. And then for the base c is 1 times negative 2, which is negative 2nd power. Hold on, I'm not done yet, because again, you could only leave your answer with positive exponents. So you're going to make it a fraction. So I'm just going to put an over 1 there, right? And you do circle arrows. All the negative exponents that you see, you're going to do circle arrow, move it down. Now, I don't move the b because the exponents is positive, so we're not going to move that. So that becomes b to the 4th power over 4 squared, a to the 6th, and c squared. Now, if you have an exponent that you could easily evaluate, you do not leave that as your final answer. You're going to change the 4 squared to 16. So final answer, it's going to be, I'm going to put it on the top, b to the 4th power over 16, a to the 6th power, c to the 2nd power. And this is your final answer. The next rule that you're going to learn is called quotient rule. So whenever you have a fraction with the same basis and with 2 different exponents, all you have to do is to have the bigger exponents subtract the smaller exponents, all right? And then you put it wherever the larger exponents is. So let's take a look at example 3a. You have 4 to the 3rd over 4 to the 6th. So what you're going to do is you're going to do 6 minus 3. Now 3 minus 6, it's easy to do 6 minus 3, which is 3, and then you put it wherever the larger exponent is. So 6 is larger and is at the bottom. So you're going to put your answer at the bottom of the fraction, which is the denominator. So you're going to put 4, and then 6 minus 3 is 3, so 4 to the 3rd. There's nothing on the top of the fraction, but you still have to put something. So we're going to put 1 like this. So it's going to be 1 over 4 to the 3rd power. Now it's easy to evaluate what's 4 to the 3rd power, so you could do 4 times 4 times 4, and you're going to get 1 over 64. So either way is acceptable for answers. In example 3 part B, you have these fractions here. So 3 times x to the 5th y to the 6th over 9 times x squared y to the 8th power. Well, first of all, let's do the same thing. Now, I see that the x's, let's actually make it a fraction first. For the x's, you do 5 minus 2, which is 3, and the 5 is larger, so you're going to put your answer on the numerator. Then for the y, you do 8 minus 6, which is 2, and 8 is larger, so you're going to put your y squared on the denominator, which is at the bottom, right? And then you do the 3 and the 9. You just copy the 3 and the 9. But hold on, this is not your final answer, because 3 over 9, you could reduce the fraction. You're gonna divide top and bottom by 3, so you're gonna have 1/3. So 3 over 9, if you reduce it, it's 1/3. So it's gonna be 1x cubed over 3y squared. Or you can make the 1 invisible, so it's gonna be x cubed over 3y squared. Either of these answers are acceptable. Finally, in example 3c, I have some negative exponents. So actually, if it's easier, let's do some circle arrow first before we, subtract negatives, because I usually don't like to subtract negatives. I get confused sometimes. So we can do circle arrow with the negative exponents. Let's move it around first, okay? So the 2 over 6 and then the m to the 6 stays there. But then the rest, everything changed now. So let me write it in the red color by extending the fraction bar. So m to the negative square, move it to the top is m squared. And then n to the negative 6, you move it to the top is n to the 6. And n to the negative 4, you move it to the bottom is n to the 4th, like this. Okay. So first of all, 2 over 6, I could reduce that by dividing top and bottom by 2, so that becomes 1/3. Then m to the 6 and m squared, you multiply them because they're next to each other. It's multiplication, so you add the exponents. So it's m to the 8th power. Then n to the 6 and n to the 4th, you subtract them because they're not multiplying, they're dividing, right? It's a fraction. So you do 6 minus 4, which is 2, and you put it on the top of the fraction because 6 is larger. So it's going to be n squared like this, okay? So you could leave that as your final answer, or you could make the 1 invisible. So m to the 8th power, n squared over 3. So these two answers are acceptable. Finally, we're in the last rule, which is quotient to a power rule. So if you have a fraction that raised to power, all you have to do is to distribute that power to all the exponents on the numerator and all the exponents on the denominator. Okay, so let's take a look at example 4a. So first of all, inside of parentheses, I see there are 3 bases. There's a 4, there's an x, and there's a y. Make sure that every basis has its own exponent. I see the x as an exponent, the y has an exponent, but the 4 does not have. So let's make it a 1 first. And then after that, you distribute the outside exponents 3 to the 1, to the 6, and to the 5, like this. So you're going to have 4 to the 1 times 3 is the 3rd power. X to the 6 times 3, which is 18th power, over y to the 5 times 3, which is the 15th power. Okay, so remember, you could simplify 4 to the 3rd, which is 4 times 4 times 4, and you get 64 x to the 18th over y to the 15th power. And that's it. Now, of course, if you don't want to evaluate 4 to the 3rd, you could leave it like this. But if it's like 4 squared, 4 to the 1st, yeah, you have to simplify that. Finally, we're on example 4b. Again, you notice that you have a big parentheses with a fraction raised to the negative 4th power. So now there's 2 ways to do it, actually. 2 ways. I'm going to show you the first way. The first way, it's going to be make sure that everything has its own exponent. So 2 to the 1st, x to the 5th, y to the negative 6 over z to the 4th, and then everything raised to the negative 4th power. Well, you're going to do distributive property first, right? So you're going to distribute the outside exponents to the inside exponents like this. You can do it that way. And then from there, you multiply all the exponents. You have 2 to the negative 4th, x to the negative 20th, y to the positive 24th power, over z to the negative 16th power. Then finally, you do circle, arrow. Okay, circle, arrow, and then circle, arrow. Okay, so that way you have, let me see, z to the 16th on the top, y to the 24th, all over 2 to the 4th, x to the 20th. And then this is your final answer. Now, of course, you could find out what's 2 to the 4th. Some of you would say that that's same as 16, and that's totally fine. So you're going to rewrite everything the same, but change 2 to the 4th to 16, and then that will work as well. So one of these 2 answers are acceptable. Okay, so again, these are exactly the same. I just changed 2 to the 4th to these number 16. Well, remember there was another way. So another way to do it is that the outside exponent is negative. So you want to do the second way. What you could do is, well, since the whole fraction has a negative exponent, you're going to flip everything upside down. So that just becomes z to the 4th all over 2x to the 5th, y to the negative 6. And then the outside exponents becomes positive. Look at that. I just flipped the fraction. Nothing really changed in the fraction other than flipping it. And then the negative 4th power on the outside becomes positive 4th power. And from there, you distribute all the exponents, right? There is a 1 here, right? So that becomes z to the 16th power, and then over 2 to the 4th, x to the 20th, y to the negative 24. And then from there, you circle arrow. Now, once you did the circle arrow, you get back to this step, right? Aren't these 2 methods the same, right? It's like a flow chart. You could do it the first method to get to this answer, or you could do the second method and you get to this answer. Either way, it will work, okay? Well, on your homework for this week, there will be a worksheet, and the following couple seconds or half a minute of video will be the selected answers for your homework. Thank you so much.